All right, so previously we talked about the wave-particle duality of photons of light. Now we're going to talk about the wave-particle duality of electrons. And so electrons are generally thought of as particles. We can actually weigh them, so we do know they have mass. So if they have mass, they must be a particle. So let's take a look at a famous experiment that was run with these electrons, and it's called the two-slit experiment. And so here we'll take a look at a particle view, and here we'll take a look at a wave view. So there's a wall with two slits. And then there's some kind of detector in the back. And what we're going to do is we're going to shoot particles at this wall, right? So obviously most particles are going to hit the wall and just bounce right back. Some particles will get through, and then we'll be able to detect them, right? And it should be the same point as the holes in the walls, right? So that's the particle view of things. Let's take a look at what happens when we shove a wave through here. So again, we have a wall with two slits. We have a detector, but this time we're shooting waves at this thing. So if you think about what's going to happen, these waves are actually going to kind of, go through these detectors, and then they're just going to keep propagating throughout the system. And so as you can see in this picture, these waves are going to interfere with one another. So this is interference. Interference with one another. And so there's two main types of interference. There's the kind when these two waves are in phase with one another. So you can see the peaks match up with the peaks and the bottoms match up with the bottoms. This is known as constructive interference. And so basically when these two waves combine, we'll get a bigger wave as a result because the peaks will add up. The other type is destructive. So in this case, they won't line up. So you can tell the opposite things here. We have a peak here, and then it's a bottom here. So if you think about adding all of these up, they destroy each other, and you'd get nothing. So through this interference on this detector, basically what you should have is a bunch of lines throughout that represent the peaks of these waves. Right. So we have a situation on the left where we have a particle, and the situation on the right, we have a wave. So let's take a look at what happens when we shoot electrons through this two-slit experiment. And remember, we think of electrons as having mass, and so thus we think of them as a particle. So they should behave like a particle, like that on the left. So let's take a look at what happens, right? So taking a look at what happens when we shoot an electron through here, and we're anticipating a particle, right? So there's an electron source here, and I'll just draw it as question marks hitting at it because we're not totally sure whether this is going to be a wave or a particle. And so when we shoot, we just see little dots, little blips start showing up, almost seemingly random. But as we let more time go, shoot more electrons through this, a pattern becomes clear. And it looks something like this. So you can see here, each electron is hitting this thing individually as though it's a particle, but overall, it's acting as a wave. You can see on the right here, what we're seeing on the detector is a property of a wave. So the electron behaves as a wave. And so when this experiment was first done, they're like, nah, no way, this can't happen. What's most likely happening is you have kind of particles coming in here and they're kind of bouncing off of each other, or they're repelling each other, that kind of thing. So that's what you've got going on. It's not actually being a wave. That doesn't make any sense. It's just a particle and your experiment's kind of messed up. And so some guy tried to say, no, you're wrong. So what I'm going to do is I'm going to shoot one electron at a time. So one E- at a time. That way, the electrons don't repel each other and we don't get this signal. And so we should be back to a particle, right? And so what happens is he shoots one at a time. He sees something like this, right? Keeps going. And then eventually what he sees is, again, the wave-like detection, And so even though you're shooting one electron at a time, what this electron is doing is it's behaving as a wave. So the electron is going through both slits, and then it's interfering with itself. So if you think about the electron as a wave, this wave comes through here. The wave will come through both portions, and then it'll grow, and then it basically interferes with itself. And so this is the two-slit experiment. You can actually recreate this with light using pretty simple stuff. So Google, two-slit at-home experiment, and you can do this experiment yourself, and you'll see that light behaves like a wave. But so do electrons. And so this was a very revolutionary idea. A lot of people tried to disprove it, but they couldn't. It's true. The electron can sometimes act as a wave and sometimes as a particle. And if we think about the wave nature of this electron, it actually helps explain quantization, right? So again, our quantization picture is we only have some values allowed. So if we think about this two-dimensional standing wave here, that's annoying. If we think about this two-dimensional standing wave, so we've got a wave behind 2 points here, and you can see here we can have kind of no nodes. Here we can have, this is a node, one node. A node is basically where it just stays at 0. We can have 2 nodes, or we can have 3 nodes. But there's no way to have this wave with 1.5 nodes, 2.5 nodes, 3.5 nodes. So we can only have integer number of nodes. An integer is just a whole number, so 1, 2, 3, 4, 5 type of thing. So this is quantized. And so if you think about an electron as a wave instead of a particle, the quantization makes sense because only certain wavelengths are going to be able to form this kind of circular wave around. If you try different wavelengths, they're basically not going to meet up, right? You'd have kind of a wave, going up here, and then this other section would kind of be going down here, and so they don't meet up. And so only certain values are allowed. If this is all very kind of confusing to you, really the only takeaway point here is that an electron is sometimes a wave and sometimes it's a particle. That's really all you need to know.